Welcome to Shital's Data Desk. Today we are diving into one of the most important topics in data world, basics of data analysis. Curious about how businesses, scientists or even YouTubers make sense of raw data? Then this video is for you. In this video, we will cover what data analysis is, why it matters, types of data, steps of analysis, tools and techniques, and some bonus tips to avoid beginner mistakes. By the end, you will have solid foundation to not just understand but start applying data analysis in real world scenarios. So, let's start with what data analysis is. Data analysis simply is a process of taking raw information and turning it into useful insights. Think of it like cooking. Raw vegetables and spices are your data, and final dish is your analysis. At its core, data analysis means identifying patterns, finding trends, and answering questions. Example: imagine shopping mall where thousands of transactions happen every single day. If you just look at raw receipts, it's overwhelming. But if you analyze that data, you might discover that people spend more on weekends or that certain stores sell 70% of its items to young adults. That's the power of analysis. It transforms messy numbers into clear answers. Now, let's move on to our next topic, why data analysis matters. People often say data is the new oil of 21st century. But just like oil, raw data by itself isn't useful until you refine it. That's what analysis does. It turns raw information into valuable insights. Without proper analysis, companies and governments face big risks, such as wrong decisions like acting on assumptions instead of facts, wasted resources like investing time and money in things that don't work, missed opportunities like overlooking trends that competitors are already capitalizing on. Now, let's see some real life examples. Netflix uses data analysis to recommend shows you are likely to binge. Amazon analyzes your browsing and purchases to suggest products you didn't even know you wanted. Governments rely on census data and surveys to plan schools, hospitals, and transport systems. Back in 1948, US newspapers famously printed headline Davy defeats Truman even before election results were in. But pollsters did big mistake. They used poor sampling for this survey. They underestimated rural voters and data misled them. Real winner was President Truman. It is powerful reminder for us. Bad data or bad analysis can create false confidence with embarrassing results. That's why data analysis matters so much. It is difference between success and failure, progress and stagnation. Now, let's move on to types of data. Understanding data types is like learning alphabets before writing. Without it, your analysis will fail. In data analysis, there are two big families of data. First, qualitative or categorical data. These are labels, names, or categories. Example: colors of cars, brands of mobile phones, or simply yes or no answers. They don't have numerical meaning, but they help us group and classify information. Second, quantitative or numerical data. This is data you can measure and express in numbers. Think of sales figures, exam scores, or temperatures. Now, numerical data itself comes into two flavors. Discrete data, which is countable. Example, number of employees in company or the number of books you own. You can't have half an employee or two and half books. And continuous data, which can take any value within range, like income, weight, or height. These values can be very precise, even to decimals. We can also classify data further into subtypes. First, nominal versus ordinal. Nominal means categories without order, like eye color or car brand. Ordinal means categories with order, like rankings, such as first place, second place, third place, and so on. And second, interval versus ratio data. Both deal with numerical data, but difference is ratio data has true zero. Example, weight or income, where zero means none. Interval data like temperature in Celsius doesn't have true zero. 0 degree doesn't mean no temperature. So, to sum up, understanding your data type is critical because it determines what analysis tools, charts, and statistical tests you can use. Now, let's go deeper into actual process of data analysis. It is not just about making charts. It has structured workflow and following it, make sure your results are reliable. Let's see main steps of process. Step 1. Define the question, meaning what exactly are you trying to find out? If you don't start with clear question, your analysis will wander aimlessly. Step 2. Data collection. This could come from surveys, company databases, sensors, or even public data sets. Step 3. Data cleaning. Real world data is messy. There are missing values, typos, duplicates. Cleaning ensures you are working with accurate information. Step 4. Data exploring is like looking at distributions, averages, correlations. This is where visualization tools like Excel, Power BI, or Tableau shine. Step 5. Data analysis. It is applying statistical techniques, building models, or running tests depending on your goals. Step 6. Result interpretation. Numbers don't mean much until you explain them in context, such as, did sales really increase because of promotion or was it just seasonal demand? Final step is insight sharing or communication. You present your findings in reports, dashboards, or presentations so others can act on them. That's the full cycle from asking question to providing actionable answer. Now that we have seen data analysis process, let's talk about tools and techniques that make all of this possible. Truth is, data analysis can be done with something as simple as Excel or as advanced as machine learning platforms. Right tool depends on your goal, your skills level, and size of your data. Let's start with basics. Excel and Google Sheets are entry points for most people. With pivot tables, formulas, and charts, you can perform powerful analysis. For example, small business owner tracking sales trend doesn't need Python. Excel is enough to spot top selling products and seasonal patterns. Next, SQL, structured query language. This is the backbone of working with databases. If you want to pull out only those customers who purchased more than 5 times or sales from last quarter, SQL is the tool. Think of it as asking questions directly to your data warehouse. For automation and deeper analysis, we move into programming languages such as Python and R. Python is most popular, with libraries like Pandas for data manipulation and Matplotlib or Seaborn for visualization. You can clean messy data, analyze millions of rows, and even build machine learning models. YouTube creator, for instance, could use Python to analyze watch time data for every video at scale, something Excel would struggle with. Then there's R. R is heavily used in academia and statistics driven industries. If you are working with advanced statistical models or predictive analytics, R shine because it has specialized packages designed for research. Now, for decision making and storytelling, we have business intelligence tools like Tableau and Power BI. These allow you to build dashboards, live, interactive visuals that executives and managers can use daily. Imagine retail chain manager opening Power BI dashboard every morning to see sales performance, inventory levels, and store-wise comparisons all in one glance. Finally, AI and machine learning tools. This is the future of data analysis. Platforms like Google AutoML or even AI features within Power BI can predict customer churn, forecast demand, or recommend next best action automatically. For example, Netflix recommendation system powered by ML is basically large scale automated data analysis. So, big idea is even if you don't know coding, tools like Excel and Power BI can take you very far. But if you want to unlock bigger opportunities such as automation and predictions, learning Python or R will put you miles ahead. Now, before you start data analysis, let me warn you about common mistakes beginners make. First, using biased data. If you only survey your friends or people like you, results won't represent whole population. Second, ignoring missing or outlier values. Skipping over gaps or unusual data points can distort real picture and lead to wrong conclusions. Third, confusing correlation with causation. Just because two things move together doesn't mean one caused the other. Ice cream sales and drowning rates both rise in summer, but one doesn't cause the other. Fourth, overcomplicating analysis with fancy tools. Beginners often jump to advanced tools when simple methods like Excel would give same insights more clearly. Finally, before we wrap up, here's what we have covered. First, data analysis turns raw data into valuable insights. Second, understand your data types. Third, follow structured 7-step process. Fourth, use right tools for job. And last but not least, avoid those common beginner mistakes. And finally, question for you. When was the last time you made data driven decision? maybe checking your phone usage stats or tracking expenses? Drop your answer below. And don't forget to like, subscribe, and check my earlier videos on sampling and population versus sample for stronger foundation. Thank you for watching.